Okay. Okay. Good morning, class. Yeah, Muda, can you hear me? Yeah, can you hear me?
Yes, Doc. We can hear you
Okay.
clearly.
Okay. Thank you very much. So today we are going to start a new topic. Today we are going to do production theory and optimization techniques. Okay. So last week we were looking at demand and supply. In fact, last week we used last week to conclude demand and supply, and today we are going to start a new topic. And today's topic we are looking at issues on production. We are looking at issues on production theory. And last week we were talking about purchasing the good. When you have high income, your demand is also high. When you don't have income,
Doc,
yeah, Muda.
the class is requesting for a recap of last week before you proceed. Is that so? Elasticity.
Okay.
They just want you to give them a recap before you dive into today's work.
Okay. So recap. So last week we looked at issues on. I'm just going to be very brief on this because I have a different topics to cover. So last week we looked at issues on elasticity, and we said elasticity.
Slow down. You can slow down a bit. It will help.
And we said elasticity is looking at what the degree. We said elasticity is looking at the degree of what of responsiveness. So by elasticity, we are looking at the degrees of responsiveness of what of quantity, okay, of quantity to changes in what in price. Because from both the law of demand and law of supply, we said there is a key relationship between what between price of a good and what and the quantity. From the law of demand perspective, once there is an increase in price, we expect quantity to fall. And once there is, a decrease in price, we expect quantity to fall. Now, the concept of elasticity is basically asking by how much will quantity, okay, change when price what changes? Because we are saying if there is a change in price, quantity should also what change. Okay, either both the supply side or the demand what side. So the concept of elasticity is looking at what by how much will the quantity change when price what changes. So you can measure that particular change by using the concept of what elasticity, which is basically looking at how responsive quantity demanded is to changes in what in price. In the case of what the price elasticity of demand. And we also have price elasticity of supply or elasticity of supply, which is looking at responsiveness of quantity supplied to changes in what in price. Okay. Now, and we said the elasticity is measured by what? By this. And we said the elasticity is just the change in what? In quantity demanded all over changes in what? In price. So this will give you a figure. This will also give you what? A figure. And we said there are a number of what types of, elasticities, right? Given what the figure that we will get. And we said first, we have what is called the elastic demand. We have what is called the elastic demand. And we said with the elastic demand, the price elasticity that you will find, okay, is greater than what? 1. Which means that if you have this as the numerator, okay, and you have this as the denominator, if this result is greater than 1, it means that the numerator, which is what the percentage change in quantity demanded, is more than the percentage change in what? In price. So in this particular case, changes in this particular case, changes in quantity demanded, okay, will be more, percentage change in quantity demanded will be more than what? Percentage change in price, which means that if you increase price by 1%, quantity demanded will increase by what? By more than what? 1%. Okay. And we said diagrammatically, if you have something like this, remember quantity here, price here. So we have our what? Our quantity here, price here. If price is increased by a small margin, what will happen to quantity demanded? We can see how much quantity demanded has fallen as a result of just one small increment in what? In price. And the other one, we said we have what? Inelastic demand. We have inelastic demand. The other one, we said we have inelastic demand. And we said for inelastic demand, the price, the elasticity, the price elasticity of demand is less than what? 1. Which means that from this formula of what? Elasticity, okay, here, percentage change in quantity demanded or a percentage change in price is less than what? 1. So for this to be less than 1, it means that the top one, which is the numerator, percentage change in what? In quantity demanded, should be what? Less than the percentage change what? In price, for this to be less than 1. Which means that for inelastic what? Demand, the percentage change in what? In quantity demanded, okay, would be what? Less than the percentage change in what? In price. Which means that if you increase price by 1%, okay, quantity demanded will also fall, but the fall in quantity demanded will be less than the increment in what? In price, which is 1%. Which means that if you increase price by 10%, quantity demanded will fall by less than what? 10%. Okay, and we said diagrammatically, we can have something like this as the demand curve, quantity, price. Okay, so if you have here as what? Quantity demanded, price here, and then you increase price to P2, what will happen to quantity demanded? Quantity demanded will fall, okay? And you realize that the change in the quantity demanded is less than the change in what? In price. So in this particular case, we say the price elasticity will be less than 1, or we say the price elasticity is what? Is inelastic. And we also mention of what? The third one, which is the unitary elastic. Unitary elastic. And we say for the unitary elastic, the percentage change in, for the unitary elastic, the percentage change in what? In quantity demanded, okay, is equal to the percentage change in what? In price. Which means that the elasticity that we are calculating as the percentage change will be the same thing as the change in what? As the change in price. Will be the same thing as the what? As the change in price, as you can see. So in this particular case, percentage change in quantity demanded will be the same as the percentage change in what? In price. And we have the others. The special ones, we are talking about what? Perfectly inelastic demand. So for perfectly inelastic demand, we are talking about a situation where, okay, we have the elasticity to be infinity. Here, we have a situation where demand curve is what? Is horizontal. As you can see here, it's just a straight line like this, which means that irrespective of the price, quantity remains what? Remains the same. Quantity remains what? Remains the same. Where we have, 0. Quantity remains the same. So here there is no change in what? In quantity. So the elasticity that we are looking at the percentage in quantity demanded all over the percentage change in what? In price. The numerator here will be 0, irrespective of the changes in price, because there's nothing like changes in what? In quantity. Okay, so in this case, our elasticity, okay, will be 0, which means that irrespective of the price, if you keep on increasing price, they sell by the same what? Quantity. And we gave the example of what? Diabetic patients who needs what? Insulin to survive. Okay. And then the last one we spoke about, the last one we spoke about, I think is the 5th one. We talked about perfectly what? Perfectly elastic. And we said for the perfectly elastic, their demand curve behaves like this. In this case, price remains what? Fixed, as quantity keeps on what? Changing. Okay, so when you pick the elasticity as the percentage change in quantity demanded all over the percentage change in what? In price. Price as the denominator remains what? Fixed. It remains fixed. It remains what? Unchanged. So the percentage change will be 0. Quantity will be changing. So the overall effect will be an what? An infinite what? Price elasticity of what? Demand. And this is the case of a perfectly competitive what? Perfectly competitive market. And we looked at the situation where we talking about the revenue side of what? Of the elasticity, as long as the type of good that you are looking at. So if the elasticity for a type of good that you are looking at is what? It's elastic. Remember, if you increase price, quantity will fall, and the fall in quantity will have implications on your what? On your total revenue. And we are saying that before the increment in price, this was the revenue. As you increase what? Price, okay, you will have what? A reduction in quantity demanded, which will affect the what? The total what? Revenue. So your new total revenue will now be this particular side, instead of what? This particular side as the initial. So you are going to lose this side of what? The revenue. You are going to lose this side of revenue, and then do what? And gain this side of revenue as a result of the increase in what? In price. So here is revenue that you will gain, and this side is revenue that you will what? Lose. So what will be the overall effect on your what? On your revenue? You will realize that the revenue that you will lose, okay, is more than the revenue that you will what? Than the revenue that you will gain. So overall, if your elasticity, if the elasticity of a good that you are selling is what? Is elastic to consumers, okay, it's not advisable for you to increase what? Price, even by a small margin, because the amount of revenue that you will lose will be more than the amount of revenue that you what? You will gain. So the overall net effect will be a reduction in what? In total revenue. But if you want to make revenue, you can say, yes, I can reduce price by 0.001. And the reduction of this particular price, the price by this particular amount, will trigger an increase in what? In quantity demanded. Because from the law of demand, we are saying that at higher price, less is demanded, okay? And at lower price, more is demanded. And because you have reduced the price by this, more will be demanded. So the revenue that you will gain will be more than the revenue that you will what? Lose. So your overall revenue will increase. That is if you are reducing the price and the good that you are looking at as an elastic demand. The opposite holds for what? For the good that is what? Inelastic. In this case, if price is here, this is the quantity. So this will be the total revenue. But you increase price to P2, and this will be the total what? Revenue. Remember, you will now lose this side of what? The revenue. You will now lose this side of revenue. So here is revenue that you will lose. And this side is the revenue that you will what? You will gain. And this side is the revenue that you will gain. Let me see. And this side is the revenue that you will gain. This is the revenue that you will what? Regain. Revenue gain. And here will be revenue what? Loss. So as you can see, if the demand for your good is what? Inelastic. If the demand for your good is inelastic, if you increase price, you will realize that the revenue gain will be more than the revenue what? Loss. As you can see, the revenue gain will be more than the revenue what? Loss. Will be more than the revenue loss. So overall, your total revenue what? Will increase if you increase what? Price. But if the good that we are looking at is elastic, overall revenue will what? Will fall if you increase what? If you increase price. If you increase price. So here an increase in price will lead to decrease in what? In total revenue. But for the elastic demand, an increase in what? In price will lead to increase in what? In total revenue, will lead to increase in total revenue. For unitary elastic, you will realize that yes, if price was P1, here will give you the same total revenue, okay? And you increase price to what? To P2, then your total revenue will change here. How much you have gained as a total, as changes in what? In revenue will be this particular side. So this is the revenue what? Gain, and how much you will lose is this particular side. And how much you will lose is this particular side, because you are now shifting to a new what? Quantity. So this side is the revenue that you will lose. What is the net effect on total revenue? You realize that the revenue that you will gain, okay, will be the same as the revenue that you will lose. So total revenue will remain what? Unchanged. So if you increase price, and the product that you are looking at has unitary elastic, total revenue will remain what? Will remain unchanged. So there will be no effect on what? On total revenue. Even if you decrease price, total revenue will still remain what? Unchanged, because the percentage change in what? In quantity demanded is the same as the percentage change in what? In price, as the percentage change in price. Now, for the perfectly inelastic, yes, the revenue was here at price what? P1. So this is total revenue. Now you have decided to increase price to P2. Then the revenue will what? Will increase again. So this is now the new revenue. This is the new revenue compared to what? To the old revenue here. You will realize that the total revenue will what? Revenue gain is this particular section. And then revenue loss will be what? Will be zero. Have they lost any revenue? No. Because irrespective of the price, they still buy. They do not reduce what? They do not change quantity. So you will not lose any revenue, and you will still be increasing what? Revenue. So for goods that are perfectly inelastic, an increase in what? In price will lead to increase in total revenue. And you will note that revenue loss will be what? Will be zero, because there wouldn't be changes in what? In quantity. There wouldn't be changes in quantity. And the last part that we are looking at is the perfectly elastic. So if the product is perfectly elastic, as you can see, quantity was Q1 when price was what? P1. In this case, if you increase price by 0.001 to P2, no one will buy. Quantity will be what? Will be zero. So in this case, your total revenue will be zero. So if the product for your good is perfectly what? Elastic, and you increase price by 0.000000001%, it will trigger overall loss in revenue. No one will buy. So your product will be what? Will be boycotted. So this is the situation for a perfect competitive market. Later, we'll be looking at this particular case, because here price is determined by the market. So the amount that you will sell your product is the same for all what? For all sellers. So you do not have to change your price. So you should know the revenue dynamics of what? The elasticity dynamics of your product, because it is critical in determining whether or not you will have higher revenue or lower revenue. So you increase or decrease the price for the goods that you are selling. So today's lecture, we are going to look at production function. I hope this is clear. This is a good recap. So let's look at production. Let's look at production theory. So let's look at production theory. Now, we are looking at a situation where we have demand and supply, we looked at a situation where we already assume the product exists and that people buy or sell at a particular given price. Now, for today's lecture, we are looking at the production side of it, and we are saying that before you produce a good, and we will say maybe a good or a commodity. So we will be using a good or a commodity interchangeably. We're using a good or a commodity interchangeably. Okay. Now, and that good or commodity, okay, here we can also add products. We can also add products. So we will be using the same terminology throughout. Okay. Now, the good or a commodity or a product, in production functions or going forward, we'll be representing it by what? By Q, as we did in the previous one. And we are saying that before a particular product is being produced, okay, there should be a combination of certain factors that are used in the production of what? A particular good, because a good do not, come from heaven. You need to, combine certain inputs, okay, to be able to what? To produce. And that particular good that we are producing, okay, it's also called what? An output. It's also called an output. And before this particular output is produced, you need to have what is called what? The input. You need what to have what? The input. And this particular input is what? The things that you will need, things you need to do what? To produce the output. To produce the output. In other words, the inputs that you will use to produce an output are key to do what? To producing a particular what? Good. So we are looking at how you will do what? You will combine your inputs to produce output. So what are the key inputs? Now, this particular key input that we are talking about in economics, okay, they are refers to what? The factors of what? Of production. The factors of production. Before we produce maybe Coca-Cola, there should be some inputs that will be used to produce that particular product, okay? Before we have our laptops, there are certain inputs that we use to produce what? That particular what? Outputs, okay? Now, so what are these factors of production that we are looking at? And remember, these factors of production are the inputs, okay, that are being used to produce what? The output. Or is the combination of what? Inputs, okay, that is required to produce a certain amount of what? Of output. Now let's look at basically what are the key factors of what? Production. Now for the key factors of production, we are looking at what? Land. Okay, you will need land to be able to establish the factory or whatever to produce that particular what? Products. Okay, you would also need a key one, which is what? Capital. Which is what? Capital, to do what? To produce it. And by this capital, largely we refer them as what? Man-made, maybe technology or techniques or whatever that you will be combining to do what? To produce that particular what? Product. The third one, we are looking at what? Labor. And by this labor, we are looking at what? The workers that you will need, okay? You will need what? Workers, okay? Factory hand to be able to combine with the above what? Products to do what? To produce that particular what? Output. In certain instances, people also add enterprise, and later we'll be looking at what? The technical change. We will decompose this capital into a number of forms. But principally, we are looking at what? These three key factors of production: land, labor, and then what? And capital. So which means that the amount of production of a certain what? Output. Of a certain output. Remember, we said this is what? Output, okay? Depends, okay? Or is produced using land. Is that not it? Using what? Labor. And then using what? and using capital. To produce this amount of what output, you will need to have a land. You will need what labor, that is people that you will be using, or your workers. And you also need to combine with certain amount of capital, all man-made equipment or machinery that you will be using to produce that particular good. They are all factored into this input, which is what? Capital. So if we go a little bit advanced, we can say that before this particular company produces what? Q, or this output, okay? The amount of output that a particular company will produce depends on these factors of what? Production, land, labor, and then what? And capital. Land, labor, and capital. However, land tends to be what? Very fixed. So we drop land in the equation. And if we drop land in the equation, which means that the amount of output that will be produced, okay, principally depends on what? On labor, and then what? And capital. Labor and capital. We can let, to avoid writing labor, capital, we can let labor be L, and then our capital will be what? Be K. So here we can simply say that the amount of output that you will produce depends on what? Capital, and then what? And labor. Depends on capital and labor. Depends on capital and labor. What we have done is to show that how much output that will be produced, okay, depends on the combination of these two key inputs, capital, and then what? And labor. So this is the production, and these are what? The inputs that you will use to produce it. You will realize that there is a link, okay, between how much is being produced and what inputs are required to do what? To produce that particular output. The link that connects output to input or factors of production. Remember, we said the inputs are what? Factors of production. So the link that connects output to input, or that connects input to what? To output. That particular link is called the production function. So that particular link, so the link, okay, between inputs, or what we call the factors of production, and output is called the production function. It's called the production function. Please note, it's called the production function, which means that the production function, or some people will also say model. Production function or model. So which means that the production function is nothing but a representation of the relationship between amount of inputs required to produce a certain amount of what? Of output. So the production function is looking at what? The input side, how much is being combined to produce what? The output side. So the relationship between input and output is illustrated by what is called the what? The production what? Function. Is illustrated by what is called the production what? Function. Therefore, if you pick a production function, this is production. In a situation where you use more capital, and less labor to produce the output, which means that your production process is what? Is capital intensive. Your production process is capital what? Intensive. Which means for capital intensive, you are using more labor and more capital than what? Than labor to produce it. You are using more capital and less labor to produce what? This output. So in this case, we say your production process is what? Is capital intensive because more capital is needed than labor to produce the output. The second part is a situation where you use what? More what? Labor, where you use more labor and then less what? Capital to produce the output. So here we say your production process is also what? It's also labor intensive. Your production process is also labor what? It's also labor intensive. It's also labor intensive. So you should know the difference. You should know the difference. Now, a typical production function, okay, like we said, exhibits this form. Let's look at the types of production function. Let's look at the types of production function. Types of production function. The first one that we will be looking at is just a linear production function. So we have a linear production function. The second one, we have another one which is called the Cobb-Douglas production function. Cobb-Douglas production function. The third one, we are looking at the Leontief production function. Output. And there are also an instance where you only need capital to produce an output without labor. And there can also be an instance where you need capital, only capital to produce without what? Labor. And the normal one that we know is a combination of what? Of the two to produce a certain amount of what? Output. Now, for the linear production function, we are looking at a situation where we show the relationship between what? Output and then input in a linear form. In other words, we do not have an exponent in how we express the relationship between what? Output and then what? And input. The Cobb-Douglas production function is also talking about what? The relationship between output and what? Input, but in a nonlinear form. So here we are talking about what? Nonlinear form. We were looking at that. We're talking about what? Nonlinear form. Now, the Leontief production function is also talking about what? How we use fixed proportion of the input. So for the Leontief, we are looking at what? The use of what? Fixed proportion. Maybe we use fixed amount of labor and we use fixed amount of what? Of capital to produce a particular good. And because we are using the one lever to produce this particular good. We are looking at the linear one. We are looking at the linear one. You will need just twice of what? Capital and then labor to produce this particular good. So before you can produce this output, you need to use twice of labor or combine with what? One capital to produce it. Or the amount of quantity or output that you can produce, you need 3 workers and just maybe one capital to produce it. This is a linear production function. And you can see this production function is largely a function of what? Capital and labor. And combination, you need 3 workers and then one what? capital to produce this particular, level of what? Level of output. Okay. Now, for the Cobb-Douglas production function, that's what we'll be using a lot, the Cobb-Douglas production function. For the Cobb-Douglas production function, we are saying that by default, a production function is saying a function of what? A production model or a function is dependent on capital and then what? And labor. Now, the Cobb-Douglas, these are names of what? Two key economists who propounded the Cobb-Douglas production function. And they said that the combination of what? Output and labor is well beyond the what? The linear form. It's well beyond the linear form. So the relationship between output and input, okay, is more than what is being shown by the simple linear relationship. In other words, the combination of our inputs are non-linearly related to what? To outputs. And they are saying that remember, it's what? It's capital, is that not it? The L is what? Labor. The L is labor. So on top of the L, we have the alpha. This is alpha. So let me write it this way. Let me just write. We have alpha. This is alpha. And this alpha is talking about what? The contribution. It's talking about the contribution of what? We can say it's capital to output. It's talking about the contribution of capital to our output. And we also have what? Beta. We also have what? Beta. And this beta is also talking about what? The contribution of what? The contribution of labor to output. The contribution of labor to output. So the Cobb-Douglas production function is expressing the relationship between output and input in a non-linear form, with each input identifying its contribution to output, okay, by the elasticities here. So here is the what? Elasticity, okay, of what? Quantity, which is the alpha. The alpha is representing the elasticity of what? Quantity or output to changes in what? In capital. And which one? Beta is also talking about what? The responsiveness of what? Output or quantity to changes in what? In labor. It will be measured by what? By beta. Now, some key properties are worth noting. Some key properties are worth noting. Now, based on the Cobb-Douglas production function, we are saying that this one alpha, this one beta. Okay, this is just a simple production function. Now, the production function can also be characterized by what? By technical change. By technical change. And this technical change is represented by what? A in the production function. So, which means that our output that we are going to produce does not only depend on what? On capital and labor, but also depends on what? A, where A is the technical change. So when you read deeper in economics, you will find what is called the AK model. So this can also be written to consider the technical change as what? Outputs, okay? As what? A, K, alpha, this one what? Beta. So this is a very basic production, Cobb-Douglas production function. This is a very basic, complete Cobb-Douglas production function, which is taking care of what the capital aspect, the labor aspect, and what technical change, which is normally assumed to be what? To be constant. Now, the key properties that we are interested in this basic form, remember alpha is looking at the contribution of what? Of capital to output. Labor, beta is also looking at the contribution of our labor to what? To output. Now, please note, if you add alpha to beta, okay, these are elasticities. If you add alpha to beta, if alpha plus beta is greater than 1, you will have what is called the increasing returns to scale. You remember, you have what is called the increasing returns to scale. The increasing returns to scale. The increasing returns to scale. What does that mean? It means that if you increase, the inputs, and what are the inputs? Capital and labor. If you increase inputs, which is what? Capital and labor, by a certain margin, output will increase by more than the change in what? In inputs. Which means that if you increase capital and labor by what? 50%, output will increase by more than what? 50%. And if you decrease output and labor by what? By 50%, if you decrease capital and labor by 50%, what will happen to output? Output will also decrease by more than what? 50%. So you can see this maybe from the perspective of the elastic what? Demand. Here, if you double the amount of what? Input, output will also increase by more than what? Doubled. Okay, by more than doubled. The second one that we are looking at is, if you add alpha and labor, alpha and beta, and it is less than what? 1. In this case, we say your production function is exhibiting what is called the decreasing returns to scale. The decreasing returns to scale. The decreasing returns to scale. And here, what does that mean? It means that if you increase output, if you increase input by a certain amount, output will also increase, but by less than the increase in the inputs. So here, if you increase inputs, which we are talking about land and what? Capital, by a certain amount, okay? Or if you change out inputs by a certain amount, output will also change, but by less than the changes in what? In output. So if capital and labor are increased by a certain amount, okay, output will also what? Increase, but by less than the changes in what? But by less than the changes the constant returns to what? To scale. By the constant returns to scale, changes in outputs, okay, would be equal to changes in what? In the inputs, would be equal to changes in the inputs. If output is increased by 60%, if input is increased by 60%, output will also change or will also increase by the same percentage, the same 50%, the same 50%. Now, let's proceed. We have some key concepts. We have some key concepts that you need to know. And for those key concepts, we are talking about what? The average product of labor. The average product. The average product of labor. And by this average product of labor, we are talking about what? The total output. The total output per unit of what? Of labor. Per unit of labor. Which means that it should pick the total output. How much is each unit of labor producing? And how much each unit of labor producing is what is called the what? The average product of what? Labor. It's what is called the average product of labor. So this is average product of what? Labor. Let me write it in full. This is average product of what? Of labor. This is average product of labor. And how much each labor unit of labor is producing is calculated as the total what? Output divided by what? Divided by labor. As the total output divided by it's also called the marginal product. The marginal products, MP. And for the marginal products, we have two things. We have marginal product of what? Of labor, which we will call MPL. And we also have what is called the marginal product of what? Of capital, which we will call the MP what? K. Which we will call the MPK. Which we will call the NPK. By the marginal product, we are looking at what? The additional, we are looking at the additional output produced. We are looking at the additional output produced by employing one unit, okay? By employing one more unit, maybe by employing one more or one additional unit. By employing one additional unit, one more or one additional unit of what? Capital or labor. So if we are looking at the marginal product, we are basically looking at what? The additional output that is produced, okay? When we employ more labor or when we employ more what? Capital, which means that from our marginal product, we can have the marginal product of labor, which is talking about what? The additional products, the additional output, okay? As a result of what? As a result of the additional output that we will produce as a result of employing one more labor, as a result of what? Employing one more unit of what? Of labor. That is what? The marginal product of labor. Now, the second one is the what? Is the marginal product of capital, which is also looking at what? The additional output produced, the additional output produced as a result of what? Employing. As a result of employing, as a result of employing, here is one more. as a result of employing one more unit of what? One more unit. In this case, it will be one more unit of what? Of capital. That is the what? That is the marginal product of what? Of capital. That is the marginal product of capital, which means our marginal product of what? Of labor would be changes in what? In output, all over changes in what? In labor. And the marginal product of capital would also be changes in what? Output, all over changes in capital, all over changes in capital, all over changes in capital, all over changes in capital. Okay, now let's go a little bit, deeper. We have marginal concepts. Marginal concepts, okay, can be characterized, can be illustrated, can be illustrated, can be illustrated using the, who can tell me? Using the concepts, marginal terms or marginal concepts can be illustrated using, calculus. We are going a little bit deeper. And this calculus, we have two: differentiation, and we also have what? Integration. We are going to consider the first aspect, which is what? Differentiation. Now, by differentiation, we are talking about what? Principally, basically, we are looking at issues on what? The marginal concepts. Now, by differentiation, let's go back in time, okay? Let's go back in time just to illustrate what we want to do. And throughout, we would be using the concept of what differentiation are going forward. Now, let's look at a simple case where you have maybe y. Let's look at a simple case where you have y is equal to maybe say a plus b, okay? A plus b, maybe x raised to the power n, remember. Okay, now here is constant. Here is constant. So the change in constant is what? Is zero. If something is constant, the each change is what? Is zero. For instance, 2, and the next period is also 2. So the change will be what? 0, because current period 2 minus what? Previous period 2, which will be what? 0. So here we will have what? The change. And by what? Differentiation, we have to do what is called what? Differentiate. So you have to differentiate. Please note, to be able to express what? The changes, okay? So we differentiate to express marginal changes. To express marginal changes. To express what? Marginal changes. Now, and to differentiate, it means that what we were talking about, changes in Q, all over changes in what? L, to represent the marginal product of what? Labor, or changes in what? Q, all over changes in what? K, to represent marginal product of capital. We can represent this one as, instead of saying what? Change in Q, we can represent this change as D, so dq. Here, dl, there's this change in L will also be what? dl. In this particular case too, for the marginal product of capital, we are also replacing the change here by what? By D. So dq all over what? D what? dk. This dq all over dl is the same as the marginal product of what? Labor. And dq all over dk is also the same thing as the marginal product of what? Of capital. So from today going, if I write dq dl, it means marginal product of labor. If I write dq dk, it also means marginal product of what? Capital, which is basically the same concept that we are looking at. But these ones are done maybe with during undergrad. In marginal terms, we will have one, the marginal product of what? Labor, and
Doc, we can't hear you.
yeah. So to express this,
Your screen is not also visible.
okay. Okay, let me just give me a few. Okay. So to express this, which is what the marginal product of capital, we need to do what? To differentiate a marginal product of labor. We need to do what? To differentiate. We need to do what? Differentiate. What are we differentiating? Output, which is what? Q. With respect to what? To labor. We need to differentiate output with respect to labor because we are looking at what? Marginal product of labor. And the second one, which is the marginal product of what? Of capital, we will also be doing the same, which is what? We will also have to differentiate. We will also have to differentiate. This we have to bring, you can first of all assume here is 0. There is nothing here. To differentiate, we hold the first side constant, okay? So to differentiate this, we have to bring this particular n, which is the exponent, first, and then deduct 1 from the exponent, which means that if you have a production function like this, the marginal product of capital would be the decay, which is what? You bring this n here. The exponents, you bring it here. This particular k will still stand. Here will be what? N, and you deduct 1 from it. So this will be the marginal product of what? Capital. So example, if output is, say, k raised to the power what? 2. Our marginal product of capital will be what? We bring this 2 here, k will stand, and it will be 2 minus 1. Here is the same thing as 2k1, which is the same thing as 2 what? K. So 2k will be the marginal product of what? Of capital. Will be the marginal product of capital. Now, if you also have something like this, Q, which is the output, okay, as K raised one will be what? 1, which is the same thing as what? 6K. So this will be the marginal product of what? Of capital, which will be the marginal product of what? Capital. It's the same thing as what? The marginal product of labor if we use L instead of what? K. If we also have this one as maybe 0.5 K raised to the power 8, and I ask you to find the marginal product of capital, it's the same thing as what? DQ all over DK. Here will be what? 8, 0.5 K, 8 minus what? 1. Here, what will you get? This times this, you will get what? 4K. 8 minus 1, you will get what? 7. So this will be the marginal product of what? Of capital. This will be the marginal product of what? Of capital. This will be the marginal product of capital. So if we combine the two factors, saying this is our output, we have this, maybe say 0.5, we have labor. And I ask you to find the marginal product of capital. Here, the marginal product of capital would be what? DQ all over DK. And here will be what? This 0.5 will come here. So it will be 0.5 AK. Remember multiplication. Here will be what? 0.5 K. Here minus 1. So here 0.5 what? Minus 1 L. So what will we get? Here will still be 0.5. Here will be what? A, K. This minus this, you have minus 0.5 L. That particular one. So we will have AK, here will just be there. Here will be what? L, 1, this particular one minus what? 1. Anytime you are differentiating with respect to a particular variable, you deduct 1 from the exponent. What will you get? 1 times all of this will still 1. So you will have AK 0.5 L. 1 minus 1 is 0. Here will be AK 0.5. Any number raised to the power 0 is what? Is 1, right? So here will be what? 1. So here will be AK 0.5 times what? 1 is the same what? Number. So this will be the marginal product of what? Of labor. This will be the marginal product of what? Of labor. This will be the marginal product of labor. Okay. This will be the marginal product of labor. Now, let's go back to the first Douglas production function.
Doc, please, can you retake that again, please?
Okay. So if we have output as, where is it? AK. If you have output as AK 0.5 L, remember, if a variable is standing alone, it means it is raised to the power 1 because any number raised to the power 1 is that number. Any number raised to the power 1 is that particular number. So which means here, our marginal product, if I ask you to find them, if you are asked to find the marginal product of what? Of capital. Remember, marginal product of capital is the same thing as differentiating the output with respect to what? To capital, which you will be finding as what? 0.5. Is that not it? AK. Remember, we are differentiating with respect to capital. So here will be the 0.5 minus what? 1. Because it's multiplying, this K will stand, this L will still be there. Here, what will you get? 0.5 AK. This will give you negative 0.5. This one too, we can still further simplify it. So we will do that in the next session. L will still be there. So this is the same thing as what? The marginal product of what? Of capital. In indices, we can still simplify this as 0.5 A. Because it's minus, it will go down as what? As a denominator, and then leaving this L. So here will be divided by what? By K raised to the power 0.5. This is the marginal product of what? Of capital. Now, the second one that we are also talking about is the marginal product of labor. And the marginal product of labor, we say you will differentiate the output with respect to what? To labor. And you go back to the question, which is here. So we are looking at the differential of what? Output with respect to labor. Labor is standing alone. And because it's standing alone, it means it is risen to the power what? 1. It's risen to the power what? 1. So we are going to bring this particular one here, which is what? Here. Okay. And then the other one is AK 0.5 L. 0.5 L. We have that particular one minus what? 1. Anytime that you are differentiating, you need to subtract 1 from the exponent. So this 1 times all of this is the same number. So we are going to have AK 0.5. Is that not it? 1 minus 1 is 0. Any number, note, any number raised to the power 0, any number or anything, any number or anything raised to the power 0 is what? Is 1. Is 1. Or anything raised to the power 0 is 1. So even if we write muda raised to the power 0, muda becomes 1. So here our marginal product of what? Labor will now be what? AK, here I'm referring to this session, will be AK, okay, would be AK raised to the power 0. Here, raised to the power 0 is 1. So we will have AK 0.5. Remember, any number, or anything raised to the power 0 is what? Is 1. So here, this times 1 is the same number. So we will have this as AK mod. So this is the marginal product of what? Of what? Of labor. Whilst this is the marginal product of what? Of capital. Of capital. Where 0.5 here is the input elasticities. Remember the contribution of what? Capital to what? To output. Now, let's go back to the standard Cobb-Douglas production function. So the standard Cobb-Douglas production function is saying output is what? AK alpha L beta. Here, how do we find the marginal product? How do we find the marginal what? Products? How do we find the marginal products? We find the marginal products using the marginal terms, using the marginal what terms. So here we are going to have what? The marginal product of what? First, the marginal product of capital, which we will find as what? Decay all over what? Decay would be what? As you can see, it's alpha. So alpha will come here. So it will be what? Alpha, AK, alpha minus 1, then beta, then L what? Beta. That is labor beta. Labor beta. Are we together? We can further simplify this as the marginal product of capital to be what? Let me just write alpha, AK, alpha minus 1, L, beta, L beta, L beta. Are we together? This can also be simplified as alpha, AK, alpha L, beta divided by, please note, here is K, and then here is what? Alpha minus what? 1. So based on our law of indices, we can divide by what? By K, which is what? Capital. Because if you send this capital to across the what? The division line, it becomes what? Minus what? 1, because it's capital. It is capital what? Capital. Okay. So this particular marginal product of what? Capital, okay, can also be expressed as alpha, this one, K alpha, L beta. What can you note? You will see that capital here, what can you see from this? You will realize that our output from the production function is AK alpha labor what? Beta. And you can see here, AK alpha labor what? Beta, which means but Q, which is the output, based on the Cobb-Douglas production function, is this one. Which means that in place of this, we can put what? Q there. In place of this, we can put Q. So we have the marginal what? Product of what? Capital to be alpha. Yeah, I didn't bring, what is the name? I didn't bring the division. Divided by what? As you can see here, divided by what? K. Divided by K. But we realize that our quantity based on our output, based on the AK model, is this one. So which means that in place of this, what we have here in the numerator, we can actually put Q there, which means our marginal product of capital, can also be rewritten as alpha Q, all over what? K, all over K, all over K. Or you can also just rewrite it as alpha Q, all over what? K. And what is alpha all over what? K? That is output per capita. And you will realize that where Q over K is output per what? Per capita. It's output per capita. Or we can also call it as what? Average output of what? Of capital. Remember first we had average output of what? Of labor as Q divided by L. So this is also the average product of capital as Q divided by what? By what? By K. So this is the marginal product of capital, which is the same thing as the GP, the Q what? GP. Now let's look at the second side of it. Let's look at the second side. And the second side is what? The marginal product of what? Of labor. So in marginal product of what? Of labor would also be dq all over what? Dl. And dp, let me just bring the...
Slow down it.
Okay, so quantity or output is given as what? Still back to the Cobb-Douglas production function. Alpha.
Sir, please slow down.
Okay.
Sir, we are fast. Please slow down.
Okay, thank you. So we have a Cobb-Douglas production function as what? AKL, and we have the input elasticities. We have finished doing the marginal product of capital. Now let's look at the second one, which is the marginal product of labor. And the marginal product of labor is the same thing as what? dq all over what? dl. Which means that we have to differentiate output with respect to what? To labor. We have to differentiate output with respect to labor, which means that the extra output that we are going to get as a result of increasing labor.
Yes, sir. Yes, sir.
Or more generally.
Sir. Yes, sir.
Yes, I can hear you.
I beg if you can slow down small. It's like you're running.
Okay.
So we have
changes in what? Output. As a result of changes in what? In labor. Is the marginal product of what? Labor. Which means how much will output change when you change labor by a certain amount? That is the marginal product, or the extra output that you will produce as a firm when you increase labor by a certain amount. Yes.
Please, can you go back a little? We are really lost.
So we are talking about the production function, the Cobb-Douglas production function. And we said the Cobb-Douglas production function is basically talking about the relationship between inputs and outputs, expressed non-linearly, as we saw in the previous sessions. And here we are talking about the marginal concept. By how much will output change when you change labor by a certain amount, or by how much will output change when you change capital by a certain amount? And we said that the marginal product of capital is measuring that amount of changes in what? In output as a result of changes in what? In capital. And we said after solving it, we found it to be this or this one. Okay. And we also said that we have the labor side of it. By how much will output change when you change labor by a certain amount? That one is denoted by what is called the marginal product of what? Of labor. And the marginal product of labor is talking about how changes in labor will affect changes in what? In output. Okay, so we use the marginal concept to do that. Specifically, we have to differentiate the output with respect to what? To labor, to be able to arrive at the marginal product of what? Of labor. Okay, now, in this particular case that we are looking at the marginal concept, we finished looking at the marginal product of labor. The second one is the marginal product of capital. The second one is the marginal product of what? Labor. So yes, we are also going to differentiate the output function with respect to labor. This is the exponent, which is the beta, showing the contribution of labor to capital. Alpha is the contribution of capital to what? To output. Okay, but our consideration is on what? Labor side. So to differentiate it, remember the key concept. You bring the exponent to the front. So here will be what? dq dl, which means changes in what? Output as a result of changes in labor is equal to the beta that we have here, then AK, I'm still just writing this one, then beta. Remember, anytime you are differentiating with respect to a particular variable, you deduct what? 1 from it, so minus 1. Minus 1. Okay, so here, the marginal product of labor is this one. And this one, you can further write this one as what? As beta AK alpha L. Remember, here can also be written as beta. Because it's minus 1, it means that the L's are true. So by law of indices, you can divide here by what? By L. You can divide here by what? L. You can divide here by L. Okay. It's the same thing as if you have something like this. Y is equal to A N all over. Okay, A N minus 1. This is the same thing as Y is equal to A N divided by A. Divided by A. It's the same thing. It's the same thing. So this one can also be written, as you can see, based on the production function. You realize that our Q here will be what? Remember the Q that we had here is AK alpha beta labor what? Beta. So AK alpha labor what? Beta, which is the same thing as here. So in place of here, we can actually put what? The Q to simplify the equation. So if we put Q into this marginal product of labor function, we are going to have the marginal product of labor, which is the same thing as what? as beta. Remember the whole thing is what? Is Q. So here will be Q divided by what? L. You can also rewrite this as beta, okay? Q divided by what? L. And what is Q divided by L? Remember we saw it. That is the average product of what? Of labor. It is also called the labor productivity. That is output per worker. So where, please note, where Q over L is the average product of what? Labor, which is measuring what is called the labor productivity. Labor productivity or output per worker. Output per worker. Output per worker. So this is the marginal product of labor. And we saw the average, the marginal product of capital too. Now, there is one particular thing that you need to know. Please note that for the production function, we are talking about the combination of what? Inputs, which is capital and labor, to produce what? Output. There can be an instant where you will have to substitute labor for what? For capital. Or an instant where you need to also substitute capital for what? For labor. And the substitution of capital for labor or capital or labor for capital is called the marginal rate of what? Technical substitution. So we have what is called the marginal rate of technical substitution. Please note the marginal rate. Marginal rate of technical substitution. Marginal rate of technical substitution, which is marginal rate of technical substitution. And what does that mean? The marginal rate of technical substitution is talking about what? The substitution of what? The substitution. The substitution of what? Inputs in the production process. The substitution of inputs in the production what? Process. So basically, by the marginal product of marginal rate of technical substitution, we are talking about what? Substitution of what? We are talking about substitution. So instead of inputs, we are talking about substitution of labor, okay, for capital. Or it can also be substitution of what? It can also be substitution of what? Capital for labor. You can reduce capital and then add more labor. Or you reduce what? Labor and add more what? Capital. The substitution of one input for the other is called the marginal rate of what? Technical substitution. Yes, you have a question.
So I wanted to find out, with regards to marginal proportion of labor, is it always that labor should be, with regards to the marginal propensity of labor,
marginal product of labor?
Part of labor, yes. Is it always that the labor should be beta minus 1?
Yes, that's what I'm saying. Anytime you are differentiating here, it's not only a marginal product of labor. Anytime you are differentiating, that is what we're doing here. That is what we're doing here. Anytime you are differentiating, you have to subtract 1 from the exponents. So let me take this one once again and you see. For instance, if we have y is equal to x, if you have y is equal to x raised to the power what? N. And you are asked to find the changes in y as a result of changes in x. It is simply dy dx. Those who did elective maths are happy. It is simply dy dx, which is what? You bring this n here in front, which is what we have brought here, and it's multiplication. So this x will still be there. The n here will still be there, but you have to deduct 1 from that particular n. So this is what you should be doing for each factor. So if I have, for instance, y is equal to 2x3 plus 2x2 plus x. dy, if I ask you to find dy dx, it will be what? You just using this. This n will come in front, which is this 3. So here will be what? 3. I'm taking it be just basic steps. This 2 is also here. X. This 3 is here. Then you deduct 1. So minus what? 1. Plus, we do the same thing here. This 2 will also come. Okay. Here will be 2. X here. This 2 will still be there. Minus what? 1. Plus, remember this is standing alone, but there is raised to the power 1 there, because any number raised to the power 1 is that number. But any number raised to the power 0 is 1. So here we have that particular 1 here. X is here. This 1 is there. Minus what? Minus 1. It's constant. You must always subtract 1. So this times this will give us 6x raised to the power 2. Plus here will be what? 4x raised to the power what? 1. Is that not it? Because 2 minus 1 plus x raised to the power 0. So here we will still have x raised to the power 2 plus 4. Any number raised to the power 1 is that number, x, plus any number raised to the power 0 is what? I just said it.
1.
It's what? It's 1. So this is our dy dx. So it's the same principle that we have been applying. It's the same principle that we have been applying. It's the same principle that we have been applying. So let's look at the marginal rate of our technical substitution. Let's proceed. So we are looking at the marginal rate of technical substitution. And I said the marginal rate of technical substitution, we can substitute what? Capital for labor, or we can also substitute labor for what? For capital. In this case, we are reducing capital and then increasing labor. So we are substituting capital for labor, or labor for capital. So we are reducing what? So we are reducing labor for more what? For more capital. Now, the marginal rate of technical substitution is talking about what? The substitution that is occurring between the two inputs to be able to produce a certain number of output. It is possible that you don't need more workers, but you need more machines to produce a particular, product. So how much labor will you be laying off? How much worker will be sucking to get more machines to produce? And it's also possible that you don't need more machines, but you rather need more workers, okay, more manpower, more laborers. So by how much of the capital or the machines will you be reducing to produce more what? To employ more labor. That concept is called the marginal rate of what? Technical substitution. And the marginal rate of technical substitution, please note, the marginal rate of technical substitution is given by the marginal product of what? Labor all over the marginal product of what? Of capital. And this is the marginal. So the marginal rate of technical substitution, labor for capital, let me add this one, is the marginal rate of technical substitution. Here is capital for labor. And then here will be the marginal product of technical substitution, the marginal rate of technical substitution, labor for what? For capital. Labor for capital. So this one, so we can have the marginal product of what? Technical substitution, capital for labor is the marginal product of what? Capital all over the marginal product of what? Of labor. And then the other one, which is the marginal rate of technical substitution, labor for capital, would be the marginal product of what? Labor, all over the marginal product of what? Of capital. So please note that the marginal product of labor, remember we found it as what? The marginal product of labor. Where is it? It's here. The marginal product of labor is beta Q all over what? L. And the marginal product of capital was alpha, where is it? Remember we found that one too? It's here. It's here. Alpha Q all over what? K. Alpha Q. Alpha Q all over what? All over K. Alpha Q all over K. So the marginal product, please note, the marginal product of what? The marginal rate of technical substitution. Capital for labor. The first one, capital for labor, is equal to, as you can see, marginal product, capital all over marginal product of what? Of labor. So what will we get? We are going to have alpha Q all over L, all over K, divided by marginal product of what? Of labor. And marginal product of labor is what? Beta Q all over what? All over what is here? All over L. So when you proceed, we are going to have the marginal product, the marginal rate of technical substitution, labor, capital for labor as what? Let me just rewrite this one. K divided by beta. So this would be what? Alpha Q all over what? K times. So you reverse it. Because we are multiplying, L will now become the numerator. So here will be times what? L all over what? Beta Q. So what will you get? Q here will cancel Q here. So we are going to have what? Alpha all over what? Capital. Times labor all over what? Beta. So when you rearrange the terms, you are going to have the marginal rate of technical substitution as what? Alpha all over what? Beta times L will stand alone all over what? K. This is the same thing as alpha all over beta labor all over what? Capital. This is the marginal rate of technical substitution. Capital for labor. Now look at something. If alpha, please note, let's play with this. If alpha and beta are homogeneous, if alpha and beta are homogeneous, it means that the unit elasticities, okay, of the two inputs, capital and labor, are the same. It means that alpha is the same thing as what? Beta, which means the contribution of capital to output is the same as the contribution of what? Labor to what? To output. So if alpha and beta are homogeneous, it means that the marginal rate of technical substitution, capital for labor, is the same as what? We have alpha here, we have beta here, we have what? Labor here, we have capital here. So if they are homogeneous, it means that alpha is the same as what? Beta. So if alpha is the same as beta, then it means our marginal rate of technical substitution, capital for labor, will be the same thing as what? Would be the same thing as what? Remember, if this and this are the same, here will be 1. So it will be 1 labor all over what? Capital. And if they are the same thing, it also means it's the same thing as what? Labor all over what? Capital. So please note that if the input elasticities are homogeneous, the marginal rate of technical substitution is just the labor per capita. So this is the same thing as what? Labor per capita. This is the same thing as labor per capita. Is this L divided by K, which is the same thing as what? Labor per capita. Labor per capita. So please note, if the input elasticities are the same, okay, marginal rate of technical substitution, capital for labor, is the same thing as what? L over what? K. The same thing applies to the marginal rate of technical substitution. The same thing applies to the marginal rate of technical substitution, labor for capital. Remember, in this case, it will be the marginal product of what? Labor all over the marginal product of what? Capital. And we found the marginal product of what? Labor to be what? What was the marginal product of labor? It's here. BQ over L. BQ, beta Q all over L, which is the marginal product of what? Labor. And then the marginal product of capital, we found it to be what? Alpha. I think it was alpha K over L. Let me just check. The marginal product of capital, yeah, alpha K is over Q. Q over L, Q over L, Q over L, Q over K. So which means the second side will be what? The marginal rate of technical substitution will be what? Alpha, marginal rate of marginal product of labor divided by marginal product of capital. So is this divided by this? So we are going to have, where is it? Beta Q all over what? L divided by alpha Q all over K. Alpha Q all over K. So this simple means beta, this one all over L times K, is that not it? Times K all over alpha what? This one. So this will 10. So this will cancel this. So what will we have? We are going to have what? Beta all over L times K all over what? Alpha. When you rearrange the terms, this is the same thing as what? Beta all over alpha dot capital all over what? Labor, which is the same thing as beta all over alpha, capital all over what? All over labor. So as you can also see, if alpha and beta are homogeneous, please note, are homogeneous. If alpha and beta are homogeneous, it means that alpha is the same thing as what? As beta. So if alpha is the same thing as beta, the marginal rate of technical substitution the marginal rate of technical substitution, labor for capital, is the same thing as this. They are the same, okay? So it means it will be 1. It will be 1. So here will be 1 times K all over what? L, which is the same thing as what? K all over what? L, which is the same thing as what? Capital per what? Labor. Remember the difference. This particular one, we found what? Where is it? Labor per capital. But here it will be what? Capital per what? Labor. Here will be capital per labor. Capital per labor. So please note the difference. So if I ask you in an exam to show that the marginal rate of technical substitution labor for capital is the same as capital per labor if the input elasticities are homogeneous, this is what you need to do. So this is the final answer. This is the final answer. So let me just take a recap. Okay, so let me just take a recap for you to see, because I will bring it in the exam. This is recap. So if I ask you to use the Cobb-Douglas production function to show that the marginal rate of technical substitution, okay, I can just say the marginal rate of technical substitution, okay, is the same as the ratio of the inputs. Please note the marginal rate. So let me just do it this way. Show that show that the marginal rate of technical substitution is the same as the ratio of the two inputs. It's the same as the ratio of the two inputs if the input elasticities are homogeneous. If the input elasticities are homogeneous, that is what we have done. So how do you show that? It's what we have done using the Cobb-Douglas production function. So we will have AK, alpha, L, beta, right? So first we need to know the marginal product of labor, the marginal product of what? Capital. And so you will know that the marginal rate of technical substitution, here I didn't say whether output capital for labor or labor for capital. So you can use any one. So you will know that the marginal product rate of technical substitution is the same as what? Marginal product of maybe say capital all over marginal product of what? Of labor. Okay, so you need to find this, you need to find this. It's as simple as that. So here we will have what? Marginal product of what? Capital, which will be what? dq all over dk, which is what? Alpha, AK, alpha L, beta, this one minus 1. So this is the same as the marginal product of what? Capital. Here will be what? Alpha, K, alpha L, beta, divided by what? K. Divided by what? K. But you will realize that this AKL raised to power, they are respect is the same thing as what? Output. So here will be what? Marginal product of capital, alpha K, all over what? Alpha Q, all over what? K. This is the marginal product of capital. Then we look for the marginal product of what? Labor. And the marginal product of labor would also be delta Q all over delta what? L, which will be what? Beta here from the production function, which will be beta, AK, L, alpha L, beta minus 1. So the marginal product of what? Labor will be the same thing as what? This one, AK alpha, L beta, remember, divided by what? L. But this whole thing is the same thing as Q, that is the output. So we can rewrite this one as beta Q all over what? L. Remember, this is the marginal product of what? Labor. So our marginal rate of technical substitution will be the marginal product. Which one are we using? Capital all over what? Labor. So capital all over what? The marginal product of labor. I'm just giving you a recap. So here will be what? What is the marginal product of capital? We found it here. Alpha Q all over what? K divided by the marginal product of labor, and we found it to be beta Q all over what? L. So here we will have what? This all over K times L all over beta Q. This will cancel this. So we are going to have what? Alpha all over K times L all over what? Beta. So if we group like terms, okay, we group the input elasticities on one side and the output and the input itself on the other side. So if you group elasticities, we are going to have alpha over what? Over beta. And you will have what? Labor all over what? Capital. Remember, the question is saying what? So this is the marginal rate of technical substitution. This is the marginal rate of technical substitution. Remember, the question is saying that you should show that the marginal rate of technical substitution is the same as the ratio of the two input. And by ratio, it's either capital divided by labor or labor divided by what? Capital. It's the same as the ratio of the two inputs if the input elasticities. And what are the input elasticities? Alpha and what? Beta. If the input elasticities are homogeneous, and by being homogeneous, it means alpha is the same as beta. Alpha and beta are the same. So in economics, if you hear something saying homogeneous, it means the same. So if the input elasticities are the same. So the question is saying that they are homogeneous. And by showing the concept of homogeneity, X, beta alpha, alpha and beta are homogeneous. And if alpha and beta are homogeneous, it means alpha is the same as what? As beta. Or the difference between alpha and beta will be 0. So if they are homogeneous, it means this divided by this is the same as 1. So if they are homogeneous, you will realize that the marginal rate of technical substitution, okay, would be what? Here and here would be 1. So they will cancel out, leaving you with what? Labor all over what? All over capital. So as we can see, so we have shown it. So this is what you need to do in an exam should this come. So we have shown it. Any question? Any question? Any question?
Any question, class? Okay,
Or
I
you
think
are
there's
confused?
no question. And we are left with 4 minutes to end. 4 minutes
Okay,
to 11.
We are left with 4 minutes. Okay. So next session. So you will realize that if the production function is exhibiting increasing returns to what? To scale. Remember, by increasing returns to scale, we said alpha plus beta will be more than 1. For decreasing returns to scale, alpha plus beta will be less than what? 0. And for constant returns to scale, alpha plus beta would be equal to what? Would be equal to 1. Now, by being homogeneous, it has implications on the elasticities, okay? And whether it is increasing or decreasing, it will also have implications on the what? On the marginal rate of what? Technical substitution. Next week, we are going to continue from these concepts and illustrate the concept of optimization, okay? And illustrate the concept of what? Optimization and decreasing returns to what? To scale. That is, as you increase more and more of labor, this particular marginal product of labor, the MPL, this particular marginal product of labor that we found as what? As beta Q all over L, as beta Q all over L should increasingly be decreasing, okay? So with this one, we are talking about what? The diminishing marginal returns, the diminishing marginal returns. So next week we will continue and do more statistics on this by identifying how many units of labor that you will need to optimize your output. So next week we'll be adding more, to this. So we are just beginning with some of the key concepts. Any question?
No. Any question? All right. So I think there's no question, Doc.
There's no question. Class, any question? Okay. So in the absence of any question, we will continue from.
Last week they want a recap.
No, we are lacking behind. That is why I'm a bit faster today. But I've not even reached where I wanted us to reach. So what
I'm telling them that business economics is not like the others. They shouldn't expect it to be too easy.
No.
Hey, they have to put on extra effort.
No. You have to put on extra effort, yeah.
It's not like the others. So, Doc, please advise them so that they will know how to catch up.
Yes, you have to study. All the materials are given. So today's what is the name? What we did today, you can find it in the book. And maybe in submitting the notes, I will add the page numbers where you can find these things there. But they are all in the book. And please, you don't have to wait last minute to start studying. Otherwise, you will be shocked. Okay.
Hello, Doc.
Yes, I can hear you.
Doc, we need to have a rare feeling of you. When I will see you? You
will see me very soon. I'm here. You can see me. I'm using video.
Doc, will you send the slide with us?
Yes.
We want to shake hands. We want to shake hands.
And the working that you just did.
Okay, so let me business economics.
So, Doc, get today and fly down to Ghana.
Huh?
I said you should get today and fly down to Ghana.
Yeah. I'll come. Okay, so I will send it immediately after this class. In the absence of any question, I wish you all the best, and then we'll catch up next week. Thank you so much.
Okay.
Bye.
Okay, bye then. Thank you. Up on the mic.